Hey algebra students, we are continuing with our 3-4, 3-5 word problem practice. This is part 2 and you should be on number 7 in your notes packet for that. So we're going to continue that 5-step process. So we start by reading the problem. Find a number that is 96 greater than its opposite. We want to choose a variable. I'm just going to choose x here, and x is going to be my unknown, and this time my unknown is just a number that I'm looking for. But each time we do want you to define your variable. Then I'm going to reread the problem and write an equation that represents the relationships among the numbers in the problem. So I'm finding a number that is, so that number that I find is, that's my equal sign, 96 greater. So that greater than and more than and less than, they all go behind. So greater than is adding, and 96, so I'm going behind. 96 more than its opposite. Well, the opposite of what? Well, the opposite of my number. So I'm going to mark it as the opposite of my number. Then I'm going to solve that equation. I need to get my variables to one side. And my constants to the other. Then, of course, you isolate the variable, get that variable by itself. Once you've solved the equation, you want to check your result with the words of the problem and give an answer. So, I would say the number is 48. We do want you to get into the habit of when you're given a word problem, you give a sentence answer. So we take a look at number 8, and we've got the length of a rectangle is 5 times its width. The perimeter is 88 centimeters, more than its width. Find the rectangle's dimensions. So we're looking for the dimensions of the rectangle. Now, anytime your problem involves some sort of geometry shape, it's going to be a good idea to do a sketch, just to make sure you're kind of keeping track of things. So I'm going to draw my rectangle and kind of plug my unknowns into the rectangle. So the length of the rectangle is 5 times its width. So what I know nothing about is usually what I want to base my variable on. And so I know that the length is 5 times the width, but I don't know anything about the width. So the width is what I'm going to use as my variable. And I'm going to define that variable. And we usually like to mention what we're measuring in, and we're measuring in centimeters here. And then the other thing I'm trying to find, because I'm trying to find the dimensions, is the length. But I do have information on the length, and the length is 5 times the width. So that allows me to write the length kind of based on the width as 5W. So I would write that as well. All right. Then I go back, reread, and set up an equation. And I have that the perimeter is 88 centimeters more than its width. So I want to think about my perimeter formula for any rectangle and use that. So I have that my perimeter is 88 centimeters more than the width. So perimeter can be represented as 2L plus 2W, but of course I don't want two variables in my equation. So instead of 2L, I want 2 times what the length is, which is 5W. So that's my perimeter. And the perimeter is, that's my equals, 88 centimeters more than. So I'm adding 88 centimeters to something. And it's 88 centimeters more than the width. So that's 88 more than W. Then I would solve my equation. So I want to simplify. Combine my like terms. Get all my variables to one side and all my constants to the other. And then isolate the variable. Now I need to make sure that I'm answering the question. I just found that the width of the rectangle is 8 centimeters, but I was asked for the dimensions. So I also need to make sure that I plug that in to find the length. And then I want to answer the question. I'm having trouble with zooming in here. All right, there we go. So the dimensions of the rectangle are 8 centimeters and 40 centimeters. So this next one, just kind of amping up to include a little more story with our problem, with our story problem. And we want to still read through and look for our unknowns. Lynn took a taxi cab from her house to the airport. She had to pay a flat fee of $2.05 plus 90 cents per mile. The total cost was $5.65. How many miles was the taxi trip? So our unknown, what we're trying to find and we don't know, is miles. So I'm going to use M. I choose a variable and define it. So you can see I've defined my variable. And reread the problem and write an equation. So, she took a taxi cab. I don't really need to know that. I just need to know what I'm looking for here. And she had to pay a flat fee of $2.05. So I know that she had to pay $2.05 plus, so of course addition. She had to pay 90 cents per mile. So that's 90 cents, and that per is a really good indicator that we're multiplying. And it's per or for every mile. And her total cost, so that tells me totaling up is my equals, and that total cost was $5.65. And there's my equation. So I want to get the variable but on one side and constants to the other. And then dividing to isolate the variable. And I get M is equal to 4. And so I know that her trip was 4 miles. So for number 10, we also have a story involved. We've got a 1,000-liter tank that now contains 240 liters of water. How long will it take to fill the tank using a pump that pumps 25 liters per minute? So we're looking for how long, and our rate is in minutes. So our unknown is how many minutes it would take. So again, I'm going to define my variable as minutes, or M for minutes, to fill the tank. I'd like you to set up the equation and solve for number 10. Bring your finished equation into class. Just a hint that it doesn't come out evenly. This is a decimal answer, so don't panic. And we'll see you in class.